Welcome to Marina's Point. We are going to solve electrical written numerical question asked in MU class 4. So question we have a 10 horsepower 230 volt shunt motor takes an armature current of 6 ampere from 230 volt mains at no load which is runs at a 1200 rpm. The armature resistance is 0.25 ohm. We have to calculate a speed and electromagnetic torque when the armature takes 36 ampere with the same flux. Here we can see here what we have given data. We can see supply voltage given 230 volt, armature current at no load given 6 ampere, a speed at no load given 1200 rpm, armature resistance is 0.25 and armature current on load is 6 ampere. We have to and flux is same, and that one flux is same. So what formula we can use to solve the question is back EMF equal to V minus IA RA, that is armature current and resistance. And since flux is constant, as we know that EMF induced equal to E is EMF induced, V is supply voltage, that is supply voltage. So E is equal to V minus IA RA, and here flux is constant. So induced EMF is directly proportional to the speed. So we can apply here E1 induced EMF is directly proportional to N1 by N2. So here we can apply this formula to calculate the speed. Now, now we are going to start calculating induced back EMF no load or induced EMF. For that we will use this formula E is equal to V minus IA RA. So one we are taking at no load. So when we apply this formula, as we know that supply voltage is given to 30 and resistance and current is given. So back EMF at no load we can found to 28.5 volt. So we will simply apply this formula E is equal to V minus IA RA, and one we are taking at point no load. Okay, next, now full load. So we will take give name 2.2. For full load we are taking 2 and no load we are taking 1. Or simply you can write the induced EMF or back EMF and no load, back EMF at full load. Okay, so back EMF, when we apply formula, everything is given. Current is given, resistance is given. So simply we can calculate back EMF at full load. Now we have to calculate the speed at full load. As we already know that flux is constant, so induced EMF is directly proportional to speed. Then we can apply this formula. We have to find the speed at full load. As we know that the speed at full load is given, we already calculate induced EMF, back EMF at no load and back EMF at full load. We can easily find a speed at full load. And here we already solved and found a speed at full load. So approximate value we can write 1160. Now a speed at full load we already find. Now we have to calculate electromagnetic power developed. So electromagnetic power developed, formula for electromagnetic power developed is equal to, that means electromagnetic power developed, that we can say at full load. At full load power is equal to, as we know that VI, V is voltage, or you can say induced EMF or back EMF at full load, and at that, and current at full load. When we put the value, we already know supply voltage 230 and current, sorry, uh, induced EMF or back EMF at full load we already calculated above, and current is given 30 ampere. When, sorry, 36 ampere. When we put, we know we can found power developed, and power developed is 7 and 5.